Let's start discuss how to use the function of this crystal ball by using this example which already existing in the manual or the folder of the software future apartment with optimum quest. What we have here, this is the number of unit rented. Here is the rent per unit. I need to decide what about the best options that we need to define. What about the best rental value that I will be highlight for this project or this apartment to provide me a higher revenue and so on. This is the monthly expenses. Here is the profit and loss. Okay, let us go through this. Here mention about the minimum as the Excel sheet. You can write it remark. Minimum, maximum, and do step by step. It will be 1. Here from this define decision variables. Here when you define it will be what about it. He takes this value, this name from the cell beside it. Okay, and then you choose it will be 400 to 600, the lower limit and the upper limit. It will be discrete or continuous. We mentioned it will be discrete. Continuous, we discuss about it. This discrete, it will be take step by step $1. Okay, for 501, 502, and so on. Continuous, in this case, we can make it just 0.5 cent, 0.45 cent, 0.46, 0.326, something like this. But it is not logic. When you have to rent unit, it will be by incremental and so on, exactly by dollar and so on. Then to have close it. Then to have this inclination rate, he mentioned his theory according to his research. So it is very important that any models that you are using, it depends on your research and your data and so on. Here mentions that the rent per unit, it will be the value number of unit rented, rent per unit. When the rent price it will be increased, the number of the rent unit it will be decreased and so on. Okay, he applies this equation. He makes the slope it will be minus 0.1 from where according to his study, because he is in the business of renting the apartment. So according to his experience and so on, he mentions that it will be take this value. 85 intercept value, which is the data that we have, it will be 85. It means that 85 unit here and then 0.1 slope. Here we talk about the minimum and the maximum, 400 and 600. So everyone, it will be 400 here. You see about the cell of the equation 45. You apply C11, C11, mention C11, which is the slope, multiply by the I15, I15, which is this value. Okay, so we have 0.1 multiplied by 400 plus to the 85 plus the C12, which is the 85. So as you know, the tools, when you have some dollar sign, it means this cell, it will be fixed. Okay, so according to 85, then we take this slope as you can see it here. Okay, so just this equation present this curve that we have. Okay, here they mention according to here about the maximum, here about the 35 number of unit, it will be C11 slope multiply by 4, because here C it will be variables, as you can see it in the green mean it will be variables or uncertainty or assumption. Green it mean assumption. Okay, so the yellow it will mean decision, green it will be an assumption, blue it mean it will be define the forecast. Okay, let us do step by step. According to this, 35 C11, which is the slope, multiplied by C4, which is the value that we have, plus the C12, which is this value, and this number it will be a change. Okay, and so on. unit rented in based on demand curve. Okay, here is the number of the unit it will be rented and so on. Here is the loss, it will be a function of the equation C3, number of the rented, multiply by the cost or the rental fee, 500 in our case, minus the expenses that will be had. Okay? Okay, here takes this step. What about the expenses that we have? Monthly expenses, what he defined it to be here, it will be like this. It will be a normal distribution. Based on why normal distribution, I mentioned if you take some from textbook or you have the data you need to make analysis or your experience and so on. If you have a back data, can be approved. If you have a textbook or any reference mentions that the monthly expenses for the apartment, it will be the normal distribution. And in most cases for any reference, provide you the type of the probability as we discussed in the session of the probability distribution and provide you the mean and coefficient of variation. When you have the mean and coefficient of variation, you can define according to the standard deviation. He mentioned here, calculate the standard deviation from this. As you mentioned, we have mean, it will be available, the average, and we have the coefficient of variation with the distribution type, we can calculate the standard deviations. Okay, if the textbook provide you the standard deviation, okay, but in most cases, provide you the mean or the average, and the coefficient of variation as we discussed in statistics tools in the session of the statistics tools. So we define here the shape that will be approximate here. Let us see the gallery. For the gallery here, I need to define two things. Some called variable and uncertainty. Variables, it means something like this. Normal distribution, log normal distribution, beta, beta BERT, gamma, Weibull, maximum extreme, minimum extreme, logistic, student T or T, exponential, Pareto, okay, and also binomial, Poisson, hypergeometric, negative binomial, geometric, and so on. Okay. All this called a probability distribution would present a variable. Variable, it means a normal value. For example, normal distribution, if you present about the tallest man on your headquarter, on your office, okay, it will be follow a normal distributions because we have size, assume the average of the tallest person in the building, it will be 1.2 meter or 1.3 meters. And we have someone which is very short man, and we have someone which is very long, very tall. Okay, very tall man, very short man. It will be little, maybe one on the building which is the shortest one, and one or two in the building which is the longest one, according to the how many person in the normal. When you have the exam, or in the faculty or the college itself, when you have the degree, just 10%. Or 5% have excellent, 1% or 5% which is losing all the courses, all the seminar to be big zero, and the in between which is a very good and accepted and so on. Okay, so this is called a variable because we mention here according to the degree of the student. It's a variables. Okay. So it will be a variable in our case. Here in our case, he mentions that here it will be the renting cost. The cost is variables. Okay. Also the log normal distributions. We have some sort in case of the exponential when we define about, for example, the communication. How many persons on the time between average time persons in the car gas fuel. Okay, as we discussed in detail in the course of the probabilistic. Okay, so on. So, variable phenomena or variable natures, it will be defined by these distributions. Okay. The another distribution called uncertainty. Uncertainty like triangle, uniform. Okay, this is the main item that we have it. Triangle, if example for most cases or most textbook mention about the cost. In case of cost estimate, they mention that the cost it will be take a triangle shape. Triangle shape because we have most likely value, the cost of this product. We have the, in case pessimistic or optimistic, what about the highest value, expected highest value, and what expected the lowest value. Okay, so there is no, cannot be a variable. So uncertainty, I cannot define. Uniform, they mention that this parameter or this factor, probability of occurrence for any value in between, it will be the same. Okay, so probability of occurrence of any value in between, it will be the same. Okay, we have also here custom, so it will be defined by the owner itself according to character, and we have option, it will be done yes or no. So if we have something, it will be yes or no and so on. Okay, but we have another thing here for geometric or binomial or hypergeometric or Poisson, we have here a bar. However, normal, log normal, it will be a dense curve like this. Really, it's called a dense, and this called a mass. Okay, here because it will be a different. Here the tallest man or the in the building mentions that okay, we can have some man of the building, it will be 1.3 average. Maybe someone had 1.325, 1.35, 1.356. So the number can be any continuous, called the continuous curve. So this variable can take any number. Here the number should be mass, so should be 1, 2, 3 and so on, like the card, like the when you have some selected the card or the number which you have when you play a game from 1 to 6, for example. Okay, 1, 2, 3, 4, 5, 6. What? How probability that number 2 it will be existing, number 3. So in this it will be 1 or 2 or 3. Cannot be 1.5, cannot be 2.5. Okay, and so on. What about the rental? If you make variable of the rental of the room, I have 1 room and 2 room. I cannot have 1.35 room. Okay, we cannot have a 1.5 room. 1 room, 2 room, 3 room, and so on. So we need to differentiate between probability for variables and for the uncertainty. So we have uncertainty and the variables. When you define about the variable, take the probability distribution that match with your variables, tallest of the building, degree of the student, log normal in case of the load on the building, take a log normal distribution. Earthquake and seismic, it will be by beta distribution, for example. The wind load, it will be by probability distribution. Sometimes it will be my maximum stream, and so on. Okay, so when you before you start, you should have this analysis, building your model, and then define about the variable. This is the secret for this software. The very important point I talk about it here now. If you take the wrong distribution, you have the wrong data from out. Okay, so you need to make your research very good to define about the best distribution that present every variable that you have. Okay, again and again and again. The software is very easy. You can work with it very, very easy, no problem at all. Okay, very simple, and it will be built in on the, as I mentioned, when download, it will be just in the menu as a software, and we see it together. The secret on it to have a good, robust report that we define the best variable distribution, probability distribution for each variable. Okay. Okay. So we mentioned we have uncertain, we have a variable, and we have a continuous like this, like this, like this, and we have a district-like Poisson distribution, hypergeometric and geometric, and so on. Okay, and we discussed this in detail. What about the others? We have the fitting. So if you have the data, and we discuss about it in another session, if you have the data, raw data, you can provide what about the best curve that you have. Okay, and to compare what about the best curve or probabilistic distributions that match with your data. Okay, if you, for example, I don't know here, I don't know that the 15,000 or I don't know what about the probability of the monthly expenses for the apartment. Okay, but I have a history. Every month's expenses, for example, for 1 year, 2 years, 3 years, 4 years. So I have this raw data. I go to here, define, correlate. It will be the same, and they make the assumption, and they have the data or have regression analysis, and then define according to it what about the best distribution. We will discuss about it in detail later, as we mentioned before. Here's the gallery. Also, it will be from this side to side. We'll discuss about the both, and there's the fitting. So define about the range of the data. Then we have, it will be all continuous or discrete, as you mentioned, continuous, discrete, or mass, or some type continuous dash function or mass function, which is continuous or discrete, and you choose between them. And then we have some 3 factors to analyze. What about the best, to define about the best curve that match with your data. Okay, this one of the options. Okay, here, what about this? He mentioned to it, it will be minus 0.11, 0.1, 0.08. So it will be here uncertain. It is not really, it is not a variable. It is not a phenomenon. Okay, just an equation presents something. What about the else? Here, the another one, which is a triangle like this. Mention about 15.5 the minimum, the maximum. This from his experience or his data and so on. Before we run, we think about here trial. It will be 10,000. What about the best number? The textbook mentions that the best number that could provide data, it will be 7,000. Okay, but here's the default, it will be 10,000. It will be good. When you increase the trial, it provides you a higher accuracy. On the past, this software, due to capability of the computer from the past, so maybe one run like this can take around 45 minutes or 1 hour. Okay, from I think from 20 years or 30 years when I do my PhD, so simple take 1 day, 1 hours or something like this. Now it will be take less than 1 minute. Okay, so the textbook define about it. But in any way, 10,000 is very, very enough. Okay, and we have also RAM reference. Let's discuss about it. I mentioned you, it will be 10,000. Maybe we can increase or decrease as you need from here, no problem. But I think default it will be 10,000. He mentions that it will be stop in case of calculation error. Because if you have a model, this is the model that you build according to the relations, the curve. If you have the equation, some problems, the equation stop, don't run. Okay. The another one, stop when precision control limit has reached 95. For example, I have 2,500 to 2,500, which is the loss and the profit. And you have run until I reach value to 8,000 or 10,000 and more. In this case, I cannot, if the variable between them, it will be just 5%. 2,500, then last one, 2,500.01. So you need to neglect it. Okay, for example. So when you measure the trial, when the difference it will be less, can be ignored, and the confidence level here also can be changed to maybe 97, 99, and so on. If you don't step by both, he stop and at 10,000 trial. What about the sampling here? Very important. Random number generations. What about the random number generation? It's called a seed value, initial seed value. Okay. When you have an initial seed value, here define according when you have initial seed value, you should define this value. It will be 999 or 555 or whatever. Okay. Here he provides him systematic the seed value. The random numbers that he started to create as we presented in the Monte Carlo simulation technique session. We talk about the seed value or the numbers that start to make the run. What is the benefit when I make this number? It will be run the same. Only one benefit. When I make this run, okay, when you have the seed value, it will be the same, whatever 888, 555, 333, or whatever the numbers you put here. When you make this exercise or make this trial, because maybe you make a change for some factors when you make the model and you make run again. Maybe you have add some variable, run again. And maybe use another thing. You make run for yourself. Okay, and you have the report with the data. And then we need to run another run after 2 or 3 days and to present it on the screen to your boss and so on. It will be a variable on the data. For example, when you mention that the probability that it will be increased more than $300,000, okay, the profit it will be 10%. Okay, so this is the first run you mentioned done. After 2 days or after 1 days or 1 hour or whatever, you make another run, it will be give you not 10, 10.1 or 9.5. Okay, so you tell the boss it will be 10. When you make another run and you make a report or whatever, it will be 9.5. To make it every run, it will be this every exercise or every big run to be the same. You should make the seed value, it will be separate. If you just make a run, you need to find no to be. Every time it will be the seed, it will be changed, and I think it will be better. We have another sampling method, Monte Carlo simulation and Latin hypercube. Latin hypercube, Monte Carlo simulation, if you had the distributions, as you mentioned from here, and Latin hypercube. What about here? Here, if you make Latin hypercube, in most cases it will be 500 pins that you have the sample size, it will be 500. In most cases, we use Monte Carlo simulation technique. If you need something more accurate, you go to the Latin hypercube. What about Latin hypercube? I ignore it here and return again. When you have this curve like this, okay, view, cumulative probability distributions. What about 1500? It will be around 0.055, something like this. So when you have a random value, the area underneath this curve, it will be 1. So the maximum value, it will be 1. The minimum value, it will be 0. As we discussed, when you have a random value can be 0.75, for example. So come here, the software provide, it will be whatever 15.8 value and so 15,800 and so on. Another random value, maybe it will be 0.23 here, so it will be this value. What about the Latin? Latin, he makes a random value for this part and for this part and this part until 500 area. So every area that will be considered, he makes a random variable on it. When you have area on it, he makes a random variable on it and so on. Okay, so it will be not a random value for all the curve. He makes the curve discrete, pins the curves he mentioned, and every part of this curve he makes a random value in between this value, okay, according to the curve. So provide you just an inclination of this curve to be more accurate or more enhance the data if you have something complicated or need more accuracy and so on. Okay. So let us go through again references that we mentioned according to this is sampling, speed. Speed, what about normal speed or demo speed? Here's the option that will be update every trial. When you see the last trial, now we need the change of the visualization. It will be every trial or update every 1 minute, 1 second, and so on. So, minimize workbook if you need to be fastest and so on. If you have the have a huge variable and so on, you need to minimize the time you can use it. Another one, chart window. It's also through the chart window every 1 second and so on, and I think it will be very important. Bring Microsoft on the foreground, not work about the Microsoft. If we have, we can to see it according to Microsoft and another, just sheet 1 for Microsoft, just to make the RAM. If you have a small RAM or the RAM, it will be very little. You can do something like this. Store assumption value for a sensitivity analysis. Keep it as it is, because in most cases you need to do sensitivity analysis. Enable correlation. We can do correlation between the data. Run set define macro for some macro in some Excel sheet. Maybe you need to make some macro for the Excel sheet. It can be done. Show control balance and make the control balance. It will be open. Statistics, the data that will be sheet. Probability above a value. It will be good. That's the presentation for it, the statistic, and make it B10, B90. If you need 10%, 90%, it will be okay, no problem for this. Okay. This is very easy for run simulation. Let us run the simulation, see about the result for it. Here's the curves that will be presented. Here is the run simulations. Okay, here's a crystal ball data assumption. We have three assumptions. We have one decision, one forecasting, and so on. Maybe you have more than one forecasting. Sure, maybe you have more than one forecasting. No problem for this. Okay. Here's the data. To see the data, we have the view. For example, cumulative distribution. This is the cumulative distribution. View statistics. Here we talk about the trial. Here's the base case. The mean, the average value. After we make the run, take the average value. What about the median? Standard deviations. Variance. Skewness. Crosses. Coefficient of variations. Minimum, it will be by minus, which is called here loss. And the profit, maximum profit, and so on. And the mean standard deviation error that we have. We can see the view that we have. Here is the curve that we have. This is the average. Here we can see it will be by negative. What about the zero value? Here's the zero value. So it will be around 84%, 48% to have a profit. Okay. So it will be for the solutions that we have. So 84 have a profit that we have. Okay. What about here? If you make it here. What about here? Okay. If I need to do something else, what about I need a profit more than certain number, or 600, for example, 6,000. So the probability to have 6,000 and more, it will be around 92.8, called it 92, so be 8%. So probability I'll have more than 90, it will be this value. Okay, then view, open sensitivity chart. Here, intercept this value. It is very important, affecting, and the slope. So this value, it will be affecting the number or the calculation of the profits that you have. Okay, more than the expenses, monthly expenses. So you need to take care about this value. This value should be defined, recheck it, and so on. So if this value, it will be, for example, the first one, intercept, it will be not accuracy not high, so it will be affect the output of your decision, and so on. Okay. So this is all about the data that we have. Maybe you have also fit probability distributions. I have distribution. What about the best fittings that I have? It will be fit the distributions. It will be to match with the beta distribution. The data, the profit or loss that we have, it will be matched with the beta distribution. He takes this data and he makes the curve that we mentioned to be here. What another? One that is, it will be the frequency. Forecast preference, it will be the frequency. Fit options, we mentioned here the fit options that we have. What about here for the fit option? It will be also auto select or continuous. You take all the curves that we have here according to auto select. What about the best ranking? It will be Anderson or KS or chi-square and so on, and discuss about it, and maybe show all the goodness of its statistics. Mention okay. Okay. Another option that we have, percent. So it will be 100%. It will be losses. We have 90%. It will be losses, and then B0, B10. It will be a probability that will be more than 5. It will be 10%. More than -6 or more than 6, it will be 100%. The minimum loss, it will be 600,000, 58, and so on. So we can define about the P80 and so on. This is just the view that we have. Define about the assumption report, about the decision variable report. Here to have, for example, the decision variable report. It will be 400, 600, that will be 1. What about the another report that I have? Create assumption for report, forecast report, for report, index and repeat, for report. So we have at the end, we have all the reports that we have with the assumption and the forecasting. Here all for this curve that you have, the assumptions, the curve of the assumptions that will be used, and makes the safety analysis also that you have. So at the end you have this report that can be used for whatever, for presentations and so on. Okay, let us go to another session, define about regression analysis and so on. Thanks a lot.